Hello Year 10. Today we are looking at rates of change. The shape of a graph shows how both the y and the rate of the change of y, which is the gradient, varies. If y increases as x increases, then the rate of change, which is the gradient, is positive. If y decreases as x increases, then the rate of change of the gradient is negative. If y does not change as x increases, then the rate of change of the gradient is 0. Straight lines have a constant rate of change. There is a fixed change in y for each unit as unit increase in x. Curves have a varying rate of change. The change in y varies for each unit increase in x. Analyzing a graph and describing how both y and the rate of change of y varies allows us to check whether a given graph models a situation accurately. Okay, so there's a bit of lingo in there, but we have some graphs here to help show what we're talking about. So in journey A, as time is progressing, as we go across horizontally, the distance is increasing. So we're going further away, but the rate at which the distance is changing is slowing down. So we say that it is decelerating as we go away from home. So down the bottom here it says the distance from home is increasing, but at a decreasing rate. So we're getting further away from home, but we are slowing down in how fast we are traveling away from home. So increasing at a decreasing rate. Whereas in journey B, we are still, as time is progressing, traveling away from home. But this time our graph is getting steeper and steeper, which means our distance is increasing at an increasing rate. Look at journey C. Journey C, as time is progressing, we've started a distance away from home and we are coming back towards home, and the gradient is getting steeper and steeper, which means the distance from home is decreasing at an increasing rate. And finally, journey D, again, we are starting away from home and moving towards home, but our gradient is quite steep to begin with and is slowing down. So the distance from home is decreasing at a decreasing rate. So what we need to do is to be able to look at some shapes. In example number 1, we have water being poured into containers at a constant rate. We want to draw a graph that shows the relationship between the height of the water in the container at different times t. So obviously we're not going to get the slopes completely perfect. We're just looking for a general idea of what the shape of the graph would look like. So as water is filling up in the bottom of this T section in here, it would be filling up at a constant rate quite quickly. So I would start with a fairly steep section for the first part of that straight line. Then as we hit the next part, because this is much wider, it's going to take a lot longer to fill that up. So it's going to slow down, but still be filling at a constant rate, but it's going to slow down. So it's going to be a slower filling for that next section. Then, once I hit the top of that cross, it's going to fill up to the same speed, at the same speed as the first section. So we want the gradient to match this first part, which would look approximately like that. Okay, so as I said, it's just an approximation of what it would look like. However, in part B, this is one rectangle the whole way, so that would be a constant rate the whole time. So it would start from being nothing in that rectangle, filling up at a constant rate, so a straight line, until it is completely full. In question 2, this distance time graph illustrates a journey by a car over a number of hours. Between what points does the graph show a speed which is 0? If the speed is 0, it means that the gradient is horizontal, it is flat. So if we look closely at our graph, it is flat here between D and E. So the speed is 0 between D and E. Then I want to find where the speed is constant. It is constant when it is a straight line. So let's have a look. That's all curving in there. This is all curving. The only part that could possibly pass for straight is between there and there, E and F. So I'm going to say the constant part is between E and F. Part 3, where is it increasing? Where the speed, we want to show where the speed is increasing. So if I look in this first section, the gradient is getting less, so it's slowing down. Between there, it's slowing down. Between B and C, that's starting quite slow and that's speeding up. So that section there is speeding up. Is there any others that are speeding up? Let's go with that one. We're going to say increasing between B and C. And then we want decreasing, so slowing down. We already found some before that was slowing down. So let's go between A and B is slowing down. And we probably could have up here as well between F and G is slowing down. So A and B and F and G. Part B, would you say that the car is travelling slower at point C compared to point E? Give a reason. So point C, let's try and make this a little bit bigger so we can see what's going on. Point C has a slope like that. Point E is a little bit harder because that's kind of changing there. Would that kind of slope in there, would that starting point there at E be steeper or not? At the start of E, it's definitely slower. It's almost horizontal, and then it starts speeding up very quickly once we go past E. So I think we would need to say that it's definitely moving faster at C because the slope is already quite steep when we hit the C, whereas E, it's flat but then increases quite rapidly after that. So we're going to write down here that it is faster at C as the graph is steeper at C than at E. Okay, it's just a few questions for you to try in exercise 7H.